Okay, so remember one thing, this critical point situation is another way, remember this critical situation another way you can say is a stable position in a certain system. In human life, in a heart pumping case, we can say once the person becomes expired, so heartbeat is stopping, so electronic cardiography graph becomes a straight line, so derivative becomes zero, is a critical situation. But in certain other situation, once the system are attaining their stable position, then we can say that critical point is zero, that there is no critical point. Okay? But let me explain this extreme value scenario in terms of increasing or decreasing. For example, once the system is moving upward, see from this point to go there, then of course is increasing, and from this point to there, from certain point extreme value, it is a decreasing case. Similarly, this extreme value, okay, in this case it is increasing, or you can say here it is decreasing. If we see the certain peaks of a graph, this value, extreme value in this and extreme value. So somewhere you can say that on a road car speed is increasing or decreasing. So once we are not accelerating the car, or we are not pressing the speed pedal, or car speed may be decreased, or we are applying the brakes, car speed can be decreased, but once we are pressing the accelerator, boosting the speed, so car speed is increased, so extreme value peak is going. Similarly, these are very simple graphs. So the absolute minimum, okay, is this. Here you can see the absolute minimum case, and this is the among all the path, the minimum position. Okay, for example, among many students, one student is getting a gold medal. It means there are only one student is getting the lowest score. Though other students are also having a low score, but one student have a minimum lowest score. This minimum score is known as absolute minimum, and the student who is getting a gold medal is known as a absolute maximum. Okay, absolute maximum. So, but students who are on a second position or third position can be say that a local maximum, or students who are not the lowest, okay, who are not getting a lowest score in a class, but almost near to the lowest score, or somehow they are known as the local minimum. So these graphs are also explaining the same thing. So, for example, there are two positions, minimum position at some point C. This is also at some point constant value C, but this is the lowest, so it is known as absolute minimum. So there are two peaks, possible peaks. You can say that this one and this one this is also at some point C, but remember this peak is lower than this peak, so maximum peak is known as absolute. This one is known as absolute maximum. So there are, okay, you can say that the position minimum, okay, so if there is only one minimum is observed, then you should not say it's the absolute minimum, you should say it's the local minimum, okay, because no comparison, so local minimum, let's see. So local maximum, similarly, if you have one peak between the 2 points, so this is known as a local maximum. For example, on a certain graph, you will see the textbook notion in form of f of a, f of b, and f of c. So absolute maximum, this one, okay, absolute maximum is this one, and absolute minimum is this one. So because this is a long graph, so not only one position, but comparison to the other big case. For example, I already explained, you start your journey from Haripur to Karachi. The highest speed of a car is known as the absolute maximum, and of course the minimum, you can say lowest speed on some, okay, maybe it is almost in a standing case, you can say that 0. So here, see, minimum is a constant, that is, in the next case you will see it's 0. Here somehow almost, so this is there are also certain scenarios you can see that absolute maximum value, absolute minimum value, but keep in mind in the, you can do not say about local maximum, local minimum for only single peak or single lower bound, lower curve. So absolute here, remember, if there is a discontinuity, okay, for example, car is moving at very high speed, at once car is applying brake, or due to certain reason car is dragging on road, car is not running, so discontinuity. DNE represent does not exist, speed does not exist, car is slipping, so then you cannot say it's the absolute maximum. Though while car is slipping, it is okay, you can say that position changing is very high, speed of the position changing from one point to another is super fast, but it's not the car tires rotation speed. So at this point absolute maximum value is none. Remember this thing, okay? So absolute, of course, if there is no, does not exist, okay? So basically car rotation does not exist in slipping case, so you can say that F is not continuous. See, tire movement is not continuous, so you can say that does not exist, so theorem does not apply here. Once theorem does not apply, you cannot say absolute maximum value is none. Or in other words, in a machine language, you can say system is at failure moment, or you can say that while engine is stopped working, okay, though aircraft is flying in air, but due to any unknown reason, due to any mishap, engine becomes fail, so aircraft landing towards the earth with huge speed, so you cannot say it's the absolute maximum, okay, though it's the speed, but it's not absolute, because engine stop working, so it's not, it's flying speed. Thank you. So similarly, this is the case once the system becomes failed, so you can say that does not exist, theorem does not apply here, so it's the fourth thing. So here slope of a tangent line at C is 0. They are very interesting. It is similar like the critical point. I already explained. This is similar to the critical point. I already explained in a video lecture what's the critical point. Once the change, there is no change, that is derivative equal to 0. So critical point. Though it doesn't matter, it's in the top, or of course it's a critical point maximum case, critical point in a minimum case. So there are different types of critical points. The most famous are the 3 types. First one is the endpoints. Endpoints of an interval. Endpoints of an interval, for example, we started our journey and we finished our journey, and that is almost, okay, see, for example, if car is at this position, a static position, or at this almost, okay, almost nearby, you can say that in a similar situation, endpoints of an interval. Endpoints of an internal are critical. Car is dead, okay, and you start your car from its static position, and once you complete your journey, you will turn off the car engine, and again car becomes static. So these are the end point of an interval, and of course there is no change. Then your derivative, okay, becomes 0. The second one is a stationary point. Okay, stationary point. Stationary points, car speed is uniform. Car speed is uniform. For example, car is moving at 60 kilometers per hour. Nowadays, electronic computing control unit or computing unit in a BMW or other Tesla cars, cruise control, that computing control the car speed. So it maintains the car speed at the same, okay, for example, 60 kilometers per hour for on a smooth road. So this is a stationary point. Then again, there is no change. My children, remember, once no change, your system, okay, is the critical point, and no change, that means no change happened, the system become equal to 0, okay. So that's a stationary point, okay. So cruise control in a car, that's all. You are a computing student, you should be familiar with it. If not, then please study from the Google, okay. Okay, singular points. Singular points, okay, this is, you can say that here, singular points are very, you can say that the crucial points, singular points, where, okay, derivative does not exist. Derivative does not exist. Why? Because system almost, for example, going this way, abrupt change, okay, abrupt change that, or you can say that very sharp, okay. See, car is moving, but on sharp bend car can accident can be happened. So usually it is known that derivative does not exist. The speed change will not matter here, okay, or will not exist here. So this is the singular point. Singular points are the sharp points, sharp edges. Okay, this is kind of this thing. So these points are also the type of critical points, and you can say, if we say the car movement, these are the accidental points. Car hit to some another car, or accident is happened. So though there is no change, okay, but that is the, you can say, sudden accident or sharp car is okay, due to some accident, car is smashing into some another hard body. So that is known as a singular points. But follow, of course, change after smashing into something, car may become stop. There is no change after that. So, but the type is not categorized in critical points. So see, this 1 and this 1 represent the endpoints. 2 represent the, okay, stationary points, stable point. At this moment car is same speed, this one is same speed almost. So the 3 1 is a sharp turning. So whatsoever, it's a singular points. Let's see some example of this. For graph the function, state the location of any absolute extreme values if applicable. Does the extreme value theorem apply? This is kind of a, okay, statement. We need to check that. First is, this one is a given function to you people. This one is a function, and this is graph the function. So this one is a, okay, graphical. Now you need to make graph for 2 possible equations. One is a 1 over x, okay, and other is a square root x. Square root x, this is the, for first, okay, this one representing, for square root, this one. This is representing 1 over x, and for square root, this one. And if, okay, they basically, for 1 over x they defined an interval minus, if minus 1 less than or equal to x or less than 0, okay, minus 1. This is minus 1, okay, less than in this situation and go almost near to less than 0. Not not if it line go, the graph go like this, then it's wrong. It must be less than 0. So other one is if 0 are equal to 0, x started from 0 and 4, 1, 2, 3 and 4. Maximum equal to 4. So these are the given values, and we will have graph. This one is the graph. Let's check it. State the location of any absolute extreme values. Is there any absolute extreme values? No. In first case, no extreme absolute values. So you can say no. In the second case, 0 to 4, 4 is the extreme absolute maximum. The extreme value theorem apply here or not? No, not applied, because there are not too many extreme values. Only one for single value, that is enough. But extreme value theorem will be applicable only when there are too many possibilities. You need to determine among too many possibilities for determining the highest extreme values. So no, so therefore no, this theorem is not required. The function is not continuous at x equal to 0. See, here this is a situation that not equal to 0. Even if here in this case -1, 0, if there is a equivalent sign, then the function can be for next function. This one is the square root x, so other function is started from 0, x less than 4. So first function started from here and goes to 0 and 0 again, equivalent. But they said that only x less than 0, strictly less than 0. So there is discontinuity. Not continuous function. So the function is not continuous at x equal to 0. So this is all the explanation of this statement. So let's see another situation. Graph the function and calculate any absolute extreme values. If applicable, plot them on the graph and state the coordinates. See, this one is a statement of some function, and -1 over x, if this situation is given, here we can say that x is starting point -2, and maximum can go to, it can be if we substitute x -1, then it will become 1. So here 1 at -1, it is a graph. You can take the derivative of this graph, this function, you will have this one. Check out, if we consider the derivative, any absolute extreme values. Let's see, let's take the derivative of this. Here, if we see, for example, in this case, we are considering the derivative equivalent to 0, then what will we have? If derivative becomes 0, then we will substitute x is what? Let's see here. X become equivalent to 0. We will substitute the value of 0 here in this equation, because if we are considering the critical point is derivative of this function equivalent to 0, then all value of x will become 0. So these are the variable we will determine on critical stage once the system is stable. So by substituting this variable x into the first equation, x is again here 1 over x, and then this by 1 over 0, system will become undefined. So it is x equal to 0 is not a critical point, not in this domain. okay, this domain. This is the closed interval, minus 2, minus 1. So critical point that system will not become equal to 0 because it does not within this domain value minus 2 to minus 1 in this interval. So critical point can be critical point now, because usually we are considering the critical point is a point where the change becomes 0, but this is not applicable here because it is out of the closed interval. So critical points can be minus 2 or minus 1 according to this situation, according to given these points. So these are the other new points. Okay, for example, weight on Earth is different due to effect of gravity. Weight on Moon is different due to effect of moon gravity. So maybe some person maximum weight on the Earth is 80 kilogram, but at Moon you can say its weight 8 kilogram. So even the situation once the child is born on Earth, its weight more than 8 kilogram, not at the 8 kilogram point, but critical is this: the system is not stable. So once we are considering the different domain, for stability of the system, it is not important that critical point is always a point that system will become equal to 0. So it can be different, okay, minus 2, minus 1, anything. So let's by substituting this critical point in the given system, so we will have 1/2. That's the absolute minimum value. By considering minus 1, we will have maximum value 1. 1 is greater than 0.5. So 1/2 equivalent to 0.5. So it is known as absolute minimum. So 1 is the absolute maximum. Therefore, considering the situation in this statement, one thing is very much important to remember, that usually in normal circumstances, critical is a point where there is no change. Change will not happen, then system will become critical, or even you can say that as I already mentioned, due to engine failure, aircraft can be landed vertically toward the Earth, though aircraft is moving. Critical point can be, okay, speed can be different than the normal flying speed. So remember that critical point system become failure, okay, no change in the system, but the critical situation is critical, okay. So this, but in out of the domain, out of the control, the critical point. Thank you so much. So another situation, calculate any absolute extreme values, state their identities and coordinates. So this one is a statement, and you are taking the first derivative and differentiate with respect to x, and you are getting this situation. And let's check out very simple, okay, critical points 0. By substituting 0 in this situation, you will get the two possible solutions. So x, you are basically, by considering the critical situation equivalent to 0, you are determining the variable or reason or situation or the engine speed or whatsoever, or the body health or the static position variable at rest, okay. So these are the variable -2 and 0. So here critical points of the system, the derivative equal to 0. So no range, no specific values is given. So we are considering the derivative equivalent to 0. So we can say, and we determine these two variable point x equal to -2 and 0 by considering the derivative at 0. Okay, so let's substitute if this derivative, okay, undefined case. In undefined case, you will have this one. See this one in the denominator. Okay, no real solution, because that is following the minus b plus minus, okay, quadratic formulae for AC our 2a, and this plus and minus sign are confused situation, so no real solutions. However, if by considering the minus, so 0 is not okay. If we see this whole system will become it's a confused system. It's not a stable system. So you need to consider the minus 2. Once you will consider the minus 2 in this equation, okay, in case of 0, first we substitute 0, then it's not okay. Explain in the denominator case, only 0 does not help. But in case of considering the minus 2, in this setup we will have minus 0, minus 0.5 absolute minimum, and on situation, this is the x value, this is the y value of the system. So by considering 0, we will have 0.5, and this is the absolute maximum case. Here, this is the supposition. Okay, this is the supposition that if this derivative is undefined. Undefined case is a case once, for example, we are considering by substituting the all. Okay, this. Okay, let me explain it. This is a system equal to minus x plus 2, and here x square plus 2x plus 2 square. See, if we are considering this whole term become 0, equal to 0, this denominator due to cross multiplication will become 0, and what we will have? We will have minus x plus 2, and so on other side we will have 0. So we will have x plus 2 equal to 0, or you can say x equal to minus 2. Again, we will have minus to the situation. So no real solution in case we are considering this as exactly as a quadratic formula. So we will not consider a quadratic formula here. We need to make the system in a simplest form. So we need to solve it out, and we will have two absolute values. One is the absolute minimum, one is the absolute maximum. Okay, there is a question from your Thomas Calculus textbook, and question is that we need to determine the this maximum values for we need to determine the current in a circuit, and this is a statement, question number 86, exercise 4.1, and in this statement we need to determine the current in a circuit, and circuit situation is given in this statement, that is I equal to 2 cos t plus 2 sin t. Basically, what is the peak current for this circuit? We need to know this peak current. But for this peak current, we are determining the situation where the critical value derivative of current with respect to time becomes 0. So this purpose, as t is given in a second, I is given in an ampere, as current is following some wave behavior along the wire or any medium. So once we are taking the derivative of the current in a circuit, it can be given in this format. So by considering this derivative, or you can say that this f dash of t equivalent to 0. So this will, we are considering this become 0 as a critical situation, and we can write this statement equivalent to 1. So this is a negative sign, this term goes on the opposite side, or by cancellation with both positive sides. So by cross multiplication we will have this one, and we can write further this as a 10 t equivalent to 1, and further we can say that t equivalent to tan inverse, and tan inverse is this one, or you can say that t equal to pi over 4. This is the value of a time in numeric things, or you can say the pi over 4. So what we need to do? We need to determine the current in a circuit, and see in this circuit, this is a circuit, and okay, we need to basically determine the value of t for determining the current in a circuit, left by considering the critical situation, by taking the first derivative, and we at the peak, okay, peak is a critical situation, or once there is no change, or at the next